Welcome to Closing the Loop, a podcast presented by Lakeside Process Controls, where we connect you with experts, end users, and suppliers in the industrial automation industry. My name is Justin Koscak, Business Unit Lead for Measurement Solutions, and your host of the show. Each episode will be featuring special guests from either Lakeside Process Controls, Emerson Automation Solutions, or other industry leaders. We hope that through these conversations, we can quite literally close the loop between your current knowledge and the latest advancements in industry. Our goal is to educate you, provide you with ideas for improving efficiency and safety throughout your facility. And with that, I'd like to introduce you to today's special guest. He's joining us from Emerson's Automation Solutions team. He's the Senior Manager for Flame and Gas Detection and Gas Analytics, and his name is Trent Riggs. Now, Trent and I have a very enjoyable conversation today where safety is of the most importance and is at the forefront of the conversation as we're talking about Rosemount's flame and gas portfolio. Now, to understand and appreciate this portfolio, we actually have to take a step back and we talk about the importance of plant and personnel safety, as well as layers of protection. And this is a really important concept to understand when it comes to safety throughout the facility, because, of course, before we can talk about flame detection, we probably want to talk about gas detection or even leak detection first. And so we want to make sure that we're using each appropriately throughout your site. We also talk about gas detectors, the different types, where to place them, how many to place them, where does it make sense. And we even talk about a really cool transmitter that looks like something from out of Star Wars, but I assure you it is of this galaxy and it is really, really cool. So stay tuned for that. I hope you enjoy the episode. As always, be sure to subscribe so that you never miss an episode. And with that, I'll turn it over and I hope you enjoy. Take care. Welcome to the show.
Yeah, thanks for having me. This is great.
So we appreciate you coming. The weather's been very cooperative as well.
Yeah.
We know traveling from Minnesota can be pretty hectic.
Yeah, it's nicer weather down here than I'm used to.
And it's down here. We always make a point of that. We are the South. It's basically like coming to Miami when you come to Toronto.
Right.
And this is not your first time in Toronto, right?
Correct. Yeah.
So you've had the occasion multiple times to be down here enjoying the six.
Right.
And all it has to offer.
Yes.
And now this time, though, you come to us wearing a different hat from Emerson. So maybe could you talk to me a little bit about maybe where you started at Emerson and kind of where you are right now, what your background is?
Sure. Yeah, I've been with Emerson for about 17 years now, and I came in as the North America product manager for our temperature product line. Did that for several years, and then passed that off and went into wireless, and then I was the wireless product manager. And then most recently, before this current role, I handled all of our agreements. So I was responsible for just working with customers on terms and the various commercial side of those. I let lawyers handle the legal side. I just did the commercial. So been in this current role for a little over a year now, and I'm really enjoying it. I like being back on the product support side.
I was going to say, you left all the boring paperwork behind, and now you're back in the plants.
That's exactly. Yeah, exactly.
That's awesome. And I didn't realize that you had wireless before. So how long ago was that?
That would have been about 10, 11 years ago is when I took it on, and then I was there for about 5 years.
So basically at the start of a lot of it?
I think I was maybe the second person to hold that wireless role.
Wow.
Yeah.
That's pretty cool. Well, they had all the growing pains,
Right.
I mean, you got to have the fun with it, right?
Right, exactly.
Oh, that's pretty cool. And then where did you go to school? Grow up? Did you grow up in Minnesota?
No, I grew up in Iowa, so not too far from Minnesota.
Yeah.
I grew up in Iowa and went to school at the University of Iowa. Got an undergraduate degree in mechanical engineering. And worked for about 10 years outside of Emerson, and got an MBA while I was working, and did that at Bradley University in Illinois, and then shortly after moved up to the Twin Cities and joined Emerson.
Been there ever since.
Yeah.
That's awesome. And so when you weren't working for Emerson, were you like an end user, or you were within the industry, or?
No, I was in the electric power industry, but working on the power generation side of things.
Oh, wow. So totally
different.
Yep. That's still cool though.
Yeah, it was fun.
I'm sure it's good background knowledge too.
It was fun. I enjoyed it.
You can dispute your energy bills.
Yeah, right.
you know it a little bit better there. Yeah. Wow, that's awesome. And so now you're looking after Rosemount flame and gas detection and the gas analysis.
Correct.
So what would that include?
So flame and gas is point gas detectors, open path gas detectors, ultrasonic leak detectors, flame detectors or fire detectors, some people call them. And then the analyzers are process gas analyzers, PGA, quantum cascade lasers. There's a leak detection product line that leverages that quantum cascade technology, and then gas chromatographs.
That's a lot.
It is a lot.
It's a big portfolio.
Yeah. Yeah.
So maybe to help start and kind of set the stage for everybody, I think Emerson does a really good job talking about layers of safety throughout a facility. Maybe you could talk a little bit about that to help put some perspective as to kind of where some of these things would fit. Sure.
Yeah. I guess, the most unique aspect in my head of the flame and gas portfolio within Emerson is it really is on that employee and plant safety side of things. Mm-hmm. Everything else we produce is more for process measurement and control. So flame and gas is really on that keeping people safe, keeping the plant safe. And so, as you say, there are layers of protection is how we approach the conversation. And so, we've kind of put a little, I'll try to paint a picture here, but, obviously the ideal protective layer is just keeping the thing in the tank or in the pipe and it doesn't get out in the first place. So the first layer of protection beyond that is identifying that there's a leak. And so that's where we have an ultrasonic leak detector to help with that. So, detecting the leak as early as possible helps you isolate the problem and fix it before it gets any worse.
And that's the Incus.
That's the Incus. Yep.
Looks like the Death Star.
Yeah, it's a pretty interesting looking device, and it's a heavy. It looks like a basketball, but it weighs about 60 pounds. So
is that how much it weighs?
Yep.
Wow, because I would think that you could easily give that a kick,
no.
roll along.
You would not want to do that.
Wow. No. Okay, that's very surprising.
Yeah, it's a big hunk of stainless steel. So.
Wow.
So first layer of protection is that just identifying when there's a leak and letting you address it before it develops into a bigger problem. And then after that, if the leak does continue to grow and build, then that's where you bring in your point gas detectors and you're looking for a dangerous concentration of gas buildup. After that, then open path gas detection would be the next layer, and that's really if that gas cloud escapes the localized area and starts to go across the plant or go outside the boundaries of the plant. You want to be able to identify that and take care of it. So that's where the open path comes in.
And this is also, it depends on if it's a combustible gas or just a toxic gas too, right? There's different solutions depending on what you got in the pipes.
Yeah, I mean, fundamentally from the outside they look like the same product, but the technology and I should say the way that they operate, it's all absorption of energy, and so it's looking for the gas is absorbing the energy of the signal beam, but it's just a different. Basically, it's one of them's UV and one of them's IR, so it's the same function, but it uses a different wavelength of light.
Just different part of the band.
Yep, exactly. So then the last layer that Emerson really has a fit for is in identifying if a combustible turns into an actual flame. You wanna obviously put that out as quickly as possible. So we have those fire detection devices, the 975, and that's their purpose, is that last final layer of protection to initiate the suppression system and keep people safe.
Yeah. Okay. Yeah, that definitely puts it into perspective because I feel like people can get lost in this world. They don't know, do they need an open path gas detector? Do they need a wearable? Do they need a flame? It's kind of funny. It's got me thinking about this one time where we had a request, and I feel like I've talked about it even on the podcast, where it was a battery storage station, and the request was for a flame detector. And I remember we were talking, we said, yeah, we can absolutely provide you with that. But if you have a flame in this battery storage station that you have here, you got a really big problem. You should probably start with, gas detection, right? Or leak detection.
Yeah.
I don't think it was under crazy high pressure. So it was more just on the gas detection side. And I remember they were saying, well, spec says flame detector, so we're going to buy a flame detector. We said, okay, your spec is terrible though, because that's not considering anybody's safety or the equipment safety, right? Because if there's a flame in there, that stuff's going to ignite pretty fast.
Yeah. Well, and that's a common a common statement that we get from customers is, this is what my spec says, and so this is what I'm looking for. And you know, there's certainly a reason to listen, and the spec's there for a reason. And so, you know, that gets back to the layers of protection. All right, we can help you meet the spec, but do you want to be safer than what the spec is telling you? Because there are these risks involved, as you say. We can help you meet the spec, but then we can also help you actually protect your people and your property, and not have the insurance claim when that fire goes out of control because all you did was meet the spec.
Exactly. And I feel like it's interesting when you get into this space, because it is, like you said before, so different in terms of, you know, what we usually talk about is process controls, right? And everything is about running that process as smooth as possible, as safe as possible. But this is really just about safety, right?
Yep.
You know, if you have 100 gas detectors, it doesn't make your plant any more efficient, right?
Correct.
So, and a lot of the people who are designing these systems, or are getting involved, or are responsible for these systems, are responsible for both systems.
Yeah.
Right. And that could be a big challenge, because this is, you know, it's like, you know, you hate paying your insurance payment every month for the car, the house. But then, of course, you need it one time, and you go, okay, well, I guess it was worthwhile. I mean, a bit of a scam. I still needed it, but, you know, it kind of feels like that.
Yeah. I mean, when I'm training new employees, the way that we message it is, there really are 4 things that customers are looking for flame and gas products for. One is personnel protection, keep your people safe. Second is protect your assets in your plant, so keep it so that you can continue producing and selling, you know, whatever product you're making. Third is meet those regulations that are you know, on your industry, that you need to be able to report to the government. So our products will help ensure that you're not releasing gas that shouldn't be released, whatever the regulation is. And then fourth is minimize environmental impact and impact to the community, because anytime a big plant has any sort of an incident, the surrounding neighborhoods are obviously concerned. And so those are really the 4 things that we talk about that these products are trying to help customers address.
So do you ever find that some customers try to use our flaming gas detection solutions for process controls, or people do a pretty good job of the understanding that there's a pretty hard line between what one's used for versus another?
Yeah, I don't think there's really any crossover there. Yeah, there's, I mean, certainly we have HART and 4-20 and Modbus outputs on our devices, but there's really no... I don't think customers would ever make the impression that they could use them for, you know, any sort of process control application.
It'd be pretty tough, you know, trying to imagine what that would look like. I just know that the lines often get blurred between, you know, gas detection versus gas analysis.
Sure.
Right. And I think that they're actually much further apart than I think most people realize.
Yeah.
Because, you know, just detecting if that gas is there versus what's actually in it. Like,
what's the composition of the gas? And,
totally different. But I guess this makes sense why you have the analysis side of the business as well.
Yeah.
Right. So maybe you could talk a little bit about that, just briefly, about, you know, what those products look like and what their intended use is for.
Yeah. So the gas analysis side of things, there's sample analyzers, so that would be like a gas chromatograph where you extract a sample from a process and you want to run it through and identify the composition of that gas and how much of a certain component is in there. And then we have the continuous gas analyzers that are meant to be an ongoing part of a process where, you know, you're running a sample through in more or less real time and getting maybe a less precise list of the gas and the compositions, but you're basically wanting to ensure that you're, you know, getting a clean combustion, or that you're getting the right blends of gases in a final product, what have you. So that's where the PGAs and the QCLs are really used, as that inline process continuous measurement.
Yeah. Okay. Yeah, that makes a lot of sense. And yeah, again, I think that makes a lot of sense too, why you handle both of those, because it's, you know, both of those solutions are incredibly important for some customers from a safety side, but then also from that process control side. And it all makes sense because you have to understand a lot about gases, right?
Exactly.
You know, how they operate, you know, some of the mechanics behind that. Okay, cool. So let's hone in a little bit on some of our gas detection solutions. Maybe you could talk a little bit about some of the technologies that we have, maybe a little bit about how they work, maybe one where one works better than the other.
Okay. Well, so if we just focus on, I guess, to start with, there's point gas and then there's the open path gas.
Yeah.
And they are very different technologies by and large. But so if we just stay with the point gas,
Yep.
You've got kind of the an NDIR sensor or a cat bead sensor if you're measuring combustibles, and then you've got the electrochem sensors for toxics. In all of those cases, you're basically placing that device close to where you think a gas release is likely. So connection points and valves and hatches and places where there's most likely going to be some sort of a gas release if it were to happen. So you try to place them there, and then you also have to think about, is this gas heavier than air, and so it'll stay close to the ground? Is it lighter than air, and therefore going to rise? That dictates also where you want to place these devices. And then another factor that sometimes gets overlooked is, okay, even if this is heavier than air, if it's coming out under pressure, it's going to go up and spread out before it comes back down. So if you put your sensor right next to the leak point or the potential leak point, it still may not catch it if you didn't account for that pressurized release, sending it up in the air a little bit before it loses that energy and falls back down. So a few things that you kind of have to think about when it comes to placing these devices. There's a few different technologies, like I say, and NDIR is I think by and large the most common for a point sensor. Cat bead, if you're trying to detect hydrogen, you've got to use a cat bead sensor. So there are some reasons why you'd select one versus the other, and that's probably the primary one between those two. And then obviously, if you're looking at toxic gases, then you need that electrochemical technology.
And so with both the cat bead and the electrochem cells, both those degrade over time, right? So that's as I understand,
Correct.
the reaction that's ongoing. Can you talk a little bit about that?
Well, yeah, they are basically using a cat bead. It's a catalytic reaction, and so the composition of the sensor changes when it detects gas. And so even when you're bump testing it, you're basically consuming the life of that sensor. Another thing to be aware of, I guess, for cat bead is it requires oxygen because it's kind of heating up and I don't want to say burning in the cell, but it requires oxygen as part of that catalytic conversion process. And so if you're in an area that's oxygen depleted or has the potential of becoming oxygen depleted when the gas appears, it makes sense to also be measuring for oxygen in that area as well, because if you don't have enough oxygen, then your cat bead sensor isn't going to detect a release.
Totally.
So, yeah.
Oh, wow. That's pretty interesting. Okay. And then NDIR, can you talk a little bit about how that one works?
Yeah. So NDIR is basically using an infrared beam that shines into the cell, and the combustible gas, when it's present in the cell, is going to absorb some of that infrared energy. And so the transmitter and the sensor pair are, they have a known intensity of that infrared signal, and as it reduces in the presence of gas, that's how the transmitter knows that methane or propane or ethylene or whatever it is that's present. That's how it knows that something is there, is because the intensity of the infrared beam is being absorbed by the gas.
So it's like a simpler version of one of our QCLs in a way.
Yeah, kind of. Simpler version is a good way of putting it. Yeah.
Very, very simple.
Yes.
I don't want to insult the QCL team. Just in the sense that it's looking at the energy, and it's kind of a unique signature depending on what's there, right?
Yeah.
Okay. And is it getting to that point where it actually can tell you, the difference between methane or ethane, or is it just you have combustibles?
It's really that you have combustibles. Okay. So there's what we call cross sensitivity.
Yeah.
So you get a sensor and have it calibrated to methane, for example.
Yeah.
It's going to tell you if propane is there, but it won't be, if you have it calibrated on methane and it is set to alarm when there's 20% methane present at the sensor, it's not going to be a direct, 20% propane will also cause it to go off. It's going to be some percentage different, but you will still get a reading on the sensor, and it'll say whatever, 16% LEL instead of 20%. But it isn't telling you that there's propane present. It's just telling you that there's some sort of a combustible gas, hydrocarbon, in the area. So,
Gotcha.
Yeah, cross sensitivity is what that's called.
Okay. And so I guess at that point it's less about, the percentage of which gas and more just, hey, there are combustibles in this air, right? And generally we're probably expecting more methane or something else.
I'd say the 80-20 rule, maybe it's even a 90-10 rule in this case. In the vast majority of installations, there's a gas that's likely to be present. There isn't going to be a choice of 4 or 5 or 6. There certainly are applications where one of a number of gases may be present, but the majority of the time the customer has a gas that they are concerned about, and so they know if the thing trips, that it's due to that specific gas.
Yeah, I'm just thinking right now, probably one of the most common examples would be, for us is dealing with natural gas, right? And looking for, gas pools of that, right? And that has a very consistent composition, depending on where you get it from, but pretty consistent composition of what that looks like.
It has, although now there's getting to be more and more hydrogen blending into natural gas. So we're getting more requests for people wanting to be able to detect hydrogen. And again, we have a technology for that. But that comes with its own challenges. Hydrogen is very difficult to detect even in its pure form because it dissipates so quickly that even if you have a cat bead sensor right there, the hydrogen very likely could just absorb into the air before the cat bead sensor is able to detect that there's an elevated amount of it.
Well, that's what I was thinking. Forget just technology to be able to measure it in a perfect, vacuum environment, just being able to capture it before it's gone, right?
Right.
But I guess then at that point, does it really matter, right? If it's floating away, unless it's pooling somewhere in your plant, you have an indoor application, now it's, at the ceiling somewhere, right? Or,
when it's coming, so when you're mixing it with natural gas, there are limits to how much can be blended in there, and that's primarily due to the potential for damage to whatever equipment that natural gas is being used to power. So boilers and furnaces and home appliances were never designed to burn hydrogen. Yeah. And so that's why there's limitations on how much you can blend into a natural gas pipeline. To your point though of, if it's leaking out and it gets absorbed, is that really an issue? Aside from obviously the lost revenue and the lost product, hydrogen is certainly more flammable and it does take a little bit of time to absorb. It just happens quickly, but if something happens close to that leak that causes it to catch fire, that's still a problem.
Yeah, totally. And I guess that's the risk. It's funny, we came back from a hydrogen convention and that's obviously top of mind, right? It's just how flammable it is. We were talking about this when you're looking at, hydrogen powered cars, right? And it's like, wow, I couldn't imagine driving a car with whatever, a couple thousand PSI tank strapped to it. But at the same time, if you get into an accident, that gas might all be gone right away if there is a leak. Yeah. Unless it's, caught flame.
Right.
then you have other issues.
Yeah, that's the big issue there. Yeah.
Yeah. So a lot of risk in those situations. But yeah, no, and it is interesting what you talk about blending it with natural gas. That's something that we've been getting more and more involved with. In our experience, though, we haven't had any crazy high percentages, though. Typically single digits. Okay. Maybe you're being asked about some low double digits or the potential for low double digits.
I've been reading some things and talking with the gas analysis teams, and some of the newer guidance coming out is up to 20% hydrogen could be blended into a natural gas pipeline. But those are upper limits and could be that's not necessarily what's actually being.
Totally. What does the piping system, what can it actually withstand? What can all the appliances withstand, right? It's a much more complex thing, but it's definitely gotten, I think, pretty interesting I mean, you're probably in a really good spot too to kind of see the hydrogen industry and how it's changed. But for us, we've been dealing with hydrogen forever, right? Like it's only now because, we're looking for alternative fuels and different kind of ways to store energy, and molecules are a great way to store energy. That hydrogen has just become this, I don't want to say big thing, but it's becoming increasingly popular, right? In terms of, maybe this is a good solution that we could consider in many of these situations.
Well, hydrogen is a renewable resource. It's not a finite resource, and it provides energy in a very similar way to the finite resources that we're used to. So that's why it can blend in and kind of be added into the existing systems. It's one of the big complaints for years on trying to convert to a battery based transport system. Just go over there. One of the big complaints on that front has for a long time been that it requires a completely different infrastructure. You can't pull up to a fuel filling station and fill up your electric vehicle. So you have to build out that infrastructure. With hydrogen blending into natural gas, you're not creating a need for new infrastructure. You can kind of blend into the same. Yeah.
Yep, totally. I mean, we have all the infrastructure that's already in place. Yep. The other problem too that it helps solve is storage, right? Storage is a big challenge. And so, I was sitting in a presentation, and they had, some big consultants who were talking about the industry at large, and their big takeaway was that, whatever you want to call it, basically molecular storage, whether it's hydrogen or ammonia or natural gas, we're not going to be able to get away from the power of molecules, right? Being able to store and transport energy that way, it really doesn't get any, better than that, especially for long-term storage, right? Yeah. We don't have batteries that can, keep energy there for 20 years, right? Like, in reality, I don't know that we would need to keep it that long, but we have caverns, we have different things to store. So there is a lot of potential in whatever that looks like, if it's hydrogen or ammonia or some other gas or some other liquid, so be it. So it's very interesting. And your products are definitely pretty cool because they touch all aspects of that industry.
Yeah.
Especially when you talk about the blending side of things too, right?
Yep.
GCs are important for that.
Yeah, they're very important on that front, and the PGAs, as I say, for kind of that custody transfer and ensuring that the product is the consistency and the makeup that it's expected to be. You wanna monitor your inputs and then monitor the outputs and make sure that nothing got lost in between. Yeah.
Totally. Yeah, so that was kind of a fun little segue into the hydrogen industry. So I do want to go back to the point though. So we started off with talking about gas detection and some of the basics. So we talked about point gas, and so point gas, I think you did a good job explaining. Basically, you want to keep it where we think the leaks are going to be. But now open path gas detection. Yeah, I don't want to call it a new technology, but I would say it's maybe less common.
Yep.
Maybe you could talk a little bit about kind of its origin and where it fits relatively.
Sure. So open path is, it's in the same vein of that NDIR conversation where you're basically using a beam of light, and the absorption of gas by that beam stipulates whether or not there's gas present. That's kind of where the similarities end, I guess, a little bit. With open path, you can separate the transmitter and the receiver by for combustibles up to about 600 or so feet, so 200 meters, I guess, for folks up here in Canada. And
we think in both.
Yeah. Do the conversion on the toxic side. That one can go up to about 200 feet. So that's what does that come out to?
I think in
70?
feet. I do both.
Okay, good. So we can separate these pretty significant distances, and then they have the ability to detect if any gas cloud passes in the beam between the transmitter and the receiver. The challenge that we face and that we talk through with customers is we can't tell you what the concentration is, because 100% concentration of gas in a 1 meter ball is the same as a 5% concentration of gas in a 20 meter ball. So The open path detector can't tell you, is this a really dangerous concentration of gas that you need to be highly concerned about? Or is this a diffuse gas cloud that you still need to be concerned about, but you could probably send someone out and they'd be okay without putting on breathers and all the safety equipment. So that's really the challenge of open path is it for a combustible, it reports in a unit of measure called an LEL meter, which is basically the percent concentration times the distance, the size of the cloud. So the easier way, that's really a meaningless number, is what it comes down to. It's a manufactured number that's just used for being able to have a device that can report something out. What we really kind of describe it as, I guess, when we talk to people, is their molecule counters. It knows how many molecules of gas are between the transmitter and receiver, and whether those molecules are really tightly together in a dense cloud or diffuse and far apart really doesn't matter. It's the same number of molecules. So that's really what OpenPath is doing. What that means in a practical application is all sites where workers are regularly present require a point gas detector to be used to monitor for gases, because you really need to know that concentration number, 20%, 30%, 40%.
I see.
An LEL meter number, like I said, it really doesn't mean anything, because a diffuse cloud can still, it has the same amount of gas potentially. So, we have customers who say, I love the idea, I love the technology, but I can't use it because I need a concentration number. And so in some cases, we'll talk to, back to that layers of protection message, we'll talk to the customer about, well, you were originally in, pick your space of room, you were going to put in a dozen point gas detectors, because point gas, you have to worry about, again, how hard is it blowing out when it leaks, and so put a gas detector in all the potential spaces where the gas may show up. If it's an outdoor location, you have to account for wind, and so you need to put multiples around an area in order to detect the gas, no matter which way the wind might be blowing, what have you. So maybe there's an opportunity to reduce the number of point gas detectors to still a safe number to be able to report the gas concentration. But then the open path gas detector is really going to do a better job of catching a gas release, because a cloud passing through a beam is much more likely to be caught than the concentration of gas dwelling at the point gas sensor for long enough for it to detect that there's gas present.
Totally. So I imagine, I think you hit one of the big advantages was the fact that, if you have a certain area, you can get away with just one open path gas detector, right? Mm-hmm. The transmitter and receiver versus maybe you would need a couple dozen, fixed point. And the challenge too is depending on the technology used for the fixed point, right? Maybe it's like a Cat B that requires, replacements or requires bump tests every now and then, versus a technology that you can just set it and forget it, right? So,
right.
That's pretty interesting. I never realized the limitation of the LEL meter and kind of, exactly your point was, hey, I have to be able to know if I can send people into this. And, but I guess I could see applications where, open path would be fine, because maybe it's an area that people don't go to, right? And it's it's an area that you want to monitor, make sure that there are no leaks, because if there are leaks here, maybe then there's elsewhere there's issues too.
Right. Yeah. Some of the interesting applications that we've had with open path are, if you have, say, a compressor room or a pump house or something where it's back to that kind of a remote location, people aren't always there, but they want to know if it's safe to open the door and go inside when they do get there. Some of these installations, they will periodically, once an hour, once every few hours, cycle the air in the room and exhaust what's in and bring in fresh. So you put an open path in the exhaust flue, and every time air cycles, it's constantly measuring and letting you know if there's any combustible gas in that exhaust. And so you know right away, because you're cycling the air in the building. So every hour, every 4 hours, whatever the frequency is, you're getting a good check of the quality of the air in there. Another good example or another good application we've seen is on the ammonia side, so on the toxic gas side. If you've got ammonia storage tanks, oftentimes those are built up with berms around them. So when the ammonia leaks, if the ammonia leaks, it falls down and hopefully gets held inside those berms. And so it has to build up quite a bit to fill up above the lip of the berm and start to flow out. Well, now you can just put an open path, invisible fence inside the berm, and as the ammonia is spilling out, it's going to fill up and cross that beam and let you know that there's a leak right away before it gets over the lip and starts to blow out.
It's funny you said invisible fence. I think of it like for the dogs, exactly like that. It is like I do picture a lot of facilities where they have it, perimeter monitoring, like being able to see what's leaking out of our facility and kind of into the neighbors, right? Keeping an eye out for that sort of thing.
Yeah.
Okay. Yeah. So that makes a lot of sense. So if you have your point gas, you have your open path. And I know this is something that Emerson doesn't dabble in, but maybe you could talk a little bit about the wearable, right? And maybe kind of how that fits into the things.
Well, I mean, yeah, obviously if you have people walking around in potentially dangerous locations, they're having those wearables on to alert them if there is a gas release in the same place that they are. That's not a technology or a product that Emerson has ever really gotten into, and I think it gets back to our roots being in the process control and that a metal a metal can, and we like to call them blue cans.
Yeah.
That doesn't really match with that clip-on tag that someone's wearing on a shirt or around their neck, sort of thing. So yeah, it's not ever really been on Emerson's roadmap to get into that space, but it's an interesting market, and it definitely fits with the keeping people safe side of what the flame and gas business is all about.
I feel like at that point, that is the last line of defense, right? Having one of those. I don't know if you know if the technology do you know if it uses cat bead, or it's probably something similar to what we're doing anyways, right? Just on a smaller scale.
Yeah.
Oh, wow. Okay, so that's pretty interesting. So now that we understand, I think, a little bit more about the gas detection, let's say one of these combustible gases has got to the point where there is a flame. Maybe you could talk a little bit about the flame detection solution that we have and how that works.
Yeah. It's potentially a big topic. How much time do we have here?
We can go all day.
Okay. So the way a flame detector works is it's looking for the presence of a fire. Some different flame detectors have slightly different methods of how they do that. Some are looking for the flicker that flames produce, and there is kind of a unique signature there. But that can get tricked. I mean, tricked is maybe the wrong word, but those types of flame detectors have a tendency to falsely identify things like grinding and some other, sparking and things that really aren't fires and aren't necessarily dangerous. They'll sometimes kind of think that those are flames because they also have a similar effect to a flickering flame. Ours are looking for kind of like a miniature gas spectrometer. They're looking for the presence of combustion elements, specifically water vapor and carbon dioxide. So if you've got a combustible fire, both of those things are going to be present, but there's going to be a lot of carbon dioxide. If you've got a hydrogen fire, really all that's going to be present is water vapor. But it's important though, if you are just focusing here for a second specifically on the hydrogen side of things, it's important to be able to detect the presence of a hydrocarbon fire as well as a hydrogen fire, because what sometimes happens is you get a hydrogen fire, which those are invisible, so they're hard to see. So you want a piece of equipment that's going to detect the presence of a hydrogen flame and let you put it out promptly. But oftentimes you'll put that fire out, but in the ensuing seconds that it took to put that out, a different thing caught fire from the hydrogen fire. That other thing is wood or cloth or what have you, and so now you have a hydrocarbon fire. Your hydrogen flame detector is no longer thinking that there's a fire anymore because it doesn't see the hydrogen product of combustion. So it's important to be looking for both hydrogen and hydrocarbon fires because oftentimes a hydrogen fire will turn into a hydrocarbon fire. And you want to obviously make sure that both of those are put out. So, we have a family of flame detectors that are, as I said, they're kind of looking for those products of combustion.
Yeah.
And, the key thing to keep in mind is they have to be line of sight to where the fire is. So even though ours aren't visibly looking for that flicker of a flame or a picture of a fire, they're looking for that gas spectrometry, spectroscopy of the products of combustion. If there's something between where the fire is and that flame detector, it's not going to detect those gases.
Like a wall?
The wall is the obvious one. You just put a couple more flame detectors around. But, if there's temporary, things are set in the way periodically. So, you walk around a space and you say, oh, yeah, for here we should probably put flame detectors in the corners, maybe a couple here in the middle, and that should cover it. If you're not thinking about how the space is used and that periodically there's big equipment, or one of the ones that's maybe easier to think through is if you have a giant airplane hangar and you say, all right, we want to protect this entire hangar, so let's put these around. Well, as soon as you bring a plane in, obviously you can't see on the other side of the plane, so you need to account for the use of the space and make sure that you're watching from all angles to properly detect a fire, obviously. So those are like the really critical things to think about as you're looking for placing flame detectors. But specifically on the Emerson family of flame detectors, we've made some really interesting enhancements to the product line here in the last couple of years that are worth knowing. And one of them is we can detect flames out to 90 meters.
Oh, wow.
The previous generation of our flame detectors could go out to 65 meters. And that's more or less the industry standard.
Yeah.
And the reason that's a big deal, obviously, you can talk about being able to monitor the same size space with fewer detectors, and so you save money there. That's certainly one side of it. But the other side is that maximum distance, that 90 meters or that 65 meters. That's all new out of the box ideal conditions. Nothing causing problems. In reality, there's always going to be something that reduces the maximum distance where a fire can be seen. And so if you start out at 90 meters, you reduce from there and you're still protected. So the further out we can detect fires, the better it is for real life usage. And some of those things that will impact detection is the lens dirty or coated in dust? That's going to cause it to not be able to see quite as far. Is there fog or rain or snow in the air? That's going to cause it to not be able to see as far. Is the fire maybe not directly in the center line of vision of the flame detector? If it's off to one of the edges, it can't see to that full distance. So when we say 90 meters, that's the standard fire test, which is a 1 foot by 1 foot square pan fire of gasoline or N-heptane at 90 meters in the center of the vision. So any other type of hydrocarbon isn't necessarily at that same 90 meter level. So if the fire is some other fuel source beyond N-heptane or gasoline, so diesel or butane or whatever, it's a shorter distance. So you gotta kind of account for the fuel source of the fire, over time as the lens gets dirty or coated in dust and some of those other things. So it's kind of unique. So as I said, we have the ability to go out farther. We also have some diagnostics in the unit, so it will actually tell you if the lens is dirty and needs to be cleaned. If you set one of our flame detectors and point it at your zone of interest, it'll actually let you know if it's no longer looking in that same spot. So if a tech comes out and bends it down to get easier access to the terminal compartment and forgets to put it back in the same spot, it'll let you know.
Oh, that's pretty cool.
Yeah, if it gets, down in the southern part of the U.S., if there's a tornado or a hurricane that kind of knocks it out of position, it'll let you know that it's not looking in the same area that it should be looking at. So yeah, we've got some diagnostics in them that really help them. Again, protect your assets and make sure that it's monitoring what it's supposed to be.
How does it tell if it's moved or if it's dirty, or just by looking at the same spot over and over again? And
well, those are two different things. So how does it know if it's moved? There's basically a little gyroscope inside. So it knows if it gets bumped out of position. So
wow, okay,
yeah,
pretty
so
simple then.
yeah, you just activate that, and it once you put it in place and have it pointed in the right spot, you basically click the button that says, all right, here's where I want you to look. And then it lets you know if it ever is moved from that spot.
Wow.
Yeah. The dirty lens, basically, our device has what's called a built-in test. And so every 15 minutes, it shines a test light from inside the device. It shines through the glass to outside the device, and we have a little reflector sitting in front of the lens. It hits that reflector and bounces back in. So it is effectively an external light source, and so it uses that to check the quality of the lens, and then it also uses it as a general system check. And are my relays functional? Is everything the electronics inside the device, are they all doing what they should be doing? So it does that every 15 minutes. If it fails, then it does another one in 10 minutes. If that fails, it does another one in 2 or 3 minutes. If all three of those fail, then it goes into alarm mode and says, there's a fault in the electronics, or I guess with the dirty lens, it's not going to give you an electronics fault. It's gonna tell you that the signal light, that built-in test, is not coming through in a high enough quality, and you need to go out and clean the lens. So it knows the difference between a dirty lens and my electronics are bad. So
that's pretty cool. That's almost like a smart meter verification for your.
Yeah.
That's not what you call it, is it?
It's not what we call it.
I should think about it. You heard it here first.
Okay. I'll pass that back to the team.
Yeah, that's pretty cool. And now, in terms of the distances, I see what you're saying about how different things impacted, and now that we can go 90 meters, we have a lot more to work with, I think, compared to when we had 65. So I feel like that's like that makes a lot of sense. It's kind of like when I make the comparison to radar, right, where we have more signal to noise ratio to work with the FMCW radars. To me, it's a very similar idea. There's more stuff to work with, and it's just going to be knocked back because of XYZ real conditions. Do we have some sort of table or recommendation then for distances, depending on if you have gasoline or diesel?
Yep, absolutely. Yep.
Okay.
In the product manual, it has a full table of the different types of combustible products and what the recommended distance is, or how far out it will see. So diesel, I forget the numbers off the top of my head, but diesel is much shorter, and so you look it up in the table and tell it, and there it is.
That's pretty cool.
Yep.
You learn something new every day.
Yeah.
That's why we do these things.
Good.
That's cool. So that's great. I think we did a pretty good job of covering basics of flame and gas. Maybe there's some similarities that you can talk about, at least in terms of mounting and installation. Maybe there's some best practices that you can share, or are they just totally different for each? Because I feel like that's a big question. It's I know I need these. I don't know how many I need, and I don't know where to put them.
Yeah.
And it's often a gray area, at least for us when we work with our customers, I find.
Yeah, it certainly does vary by product. So I'll just kind of maybe quick run through some of the stuff. Let's just go through the layers of protection. So the first one is the Incus. We didn't really talk much about the Incus here, but that one is a single device is meant to monitor a fairly large space.
Yeah.
And the question always follows, how big of a space?
Yeah.
And the answer is it depends. So basically the way the Incus works is it's listening for the ultrasonic signal that's emitted when a gas escapes through an orifice.
Yeah.
Gases they emit an ultrasonic sound. And so that's how the Incus works. It's listening for that. So the higher the pressure that the gas is when it releases, and the smaller the orifice it is when it releases, both of those will increase the decibel, so the loudness of that ultrasonic signal. So the higher the pressures, the smaller the orifice, the larger the area that an Incus can cover. As a so-so rule of thumb, a 40-meter radius around the thing is kind of a good starting point. Higher pressures, it could very likely hear further out.
Okay.
So to circle back to the, kind of mounting considerations, Incus is one unit is meant to monitor a fairly large space. So you go out and you evaluate the size of the space. We do like to, take some of these units into the potential location and just turn it on, and you can walk around with a nitrogen bottle or a little, ultrasonic emitter, like a dog repeller or a dog trainer device that you can buy off of Amazon for $20.
Oh, wow.
And you can just kind of walk around and see how far away it can hear a leak. And that gives you kind of in the real environment, and with the wind blowing and however loud the environment is, just kind of shows how far it can listen. So that's the consideration there, is you want that to be in the middle of the space that you want to listen to, and you put it on a post 10, 15 feet in the air, point it down, and then it's just listening to that area. So not a whole lot of mounting considerations other than getting it in the middle of the space. So the next level would be our point detectors. We talked a little bit about how those really have to be where the gas is going to be present.
Yeah.
The 925 with our 625 sensor, that's kind of the standard point sensor on a transmitter. Those need the gas to sit there for 10 seconds, depending on the technology. And if we expand to just kind of the broader point gas market, so not just the Emerson products, those sensors, maybe 8 or 10 seconds on the low end to 30 or 40 seconds on the high end, that the gas has to be present for it to be recognized. So you got to take that into consideration, and that gets back to how many sensors do I really need to put around this space and locate them low, high, where. That's really the consideration that needs to be taken for point gas. And then with open path, those, as I said earlier, those have a pretty long distance that they can go. We always recommend that you don't go to the full distance, so don't go to 600 feet on the LELs. Pull back to 75 or 80% and make that your maximum, because again, fog and rain and snow and things are going to make it hard. We've got some unique technology inside our product that gets it so that it can auto adapt and kind of power through some of those things. But still, don't set yourself up for failure. 600 feet is that ideal number. Scale it back a little bit to ensure that the thing is going to work under any conditions. And then beyond that, it's a beam of light. It's not a laser, but it is a pretty tightly focused beam of light, and so alignment is critical.
Yeah, totally.
And it needs to be mounted very rigidly onto a very solid surface. You don't want vibrating. You don't want to mount it to a chain link fence for sure, but you don't want it mounted to something with a lot of vibration running through it either. And again, if the devices are constantly kind of out of phase and bouncing in different directions at different times, it's going to struggle to maintain a solid signal. So that's the big consideration on open path, is just you want it mounted to a solid platform that is not going to be swaying in the wind or vibrating or any of those sorts of
vibrating,
things.
I feel like it's a big one.
Yeah,
We've run into that one a lot.
Yeah, for sure. And then the last product would be the flame detection. The only real consideration there is, you want it pointing at the area of interest. As I said earlier, they operate with what we call the cone of vision. So you basically, from the middle of the device, from the lens where the flame detector is facing, there's basically a 90 degree, so kind of like a baseball diamond shape of its area of view. But it's that shape in 360 degrees, more or less. So that's its cone of vision.
That makes sense.
And so what that means is you have the thing, pointing, say, 45 degrees down towards an area that you're generally interested in. Well, the top end of its vision is going to be straight out at the horizon then, because it's not just looking straight in that direction that you have it pointed. It's got that cone. And so we certainly have had cases where some installations, they put it up high and they didn't have it pointed down quite enough, and it was picking up a flare 2 miles away. So I talked about earlier how it's rated to see out to 90 meters. That's getting back to that's the 1 foot by 1 foot square pan fire at 90 meters. If something is twice as far away, so 180 meters, it still might see it if it's a big enough fire. So that's the problem. Some of these flares can be pretty large, and so even though they're a mile or two away, it's still big enough to get picked up, and that's what was happening at some of these installations. And so there are some ways. I mean, obviously you can just bend it down a little bit further. There are some visors that you put on top that basically cuts off that top bit of the cone so that it can't see out to the horizon. It can only look down. So there's some ways to address that, but it's certainly the thought process is part of the walk around and figuring out where to put these things. Is there anything at all in the background that we need to be concerned about? Are we going to have a big company barbecue in the parking lot on the backside, and when they lift and have the charcoal briquettes going, is that going to tell the thing that there's a fire and set it off? You don't want that happening.
Oh, wow. And what about if, especially if you mount the flame detector up high, what if there's a fire beneath it? Like, is there still a way for it to detect it, like with the molecules traveling upwards into that beam, or no, it has to be within that cone? Okay.
Yeah, it needs to be within that cone of vision. Yeah, it gets back to the, it's doing, I mean, I get where you're going with that. But it isn't really like a gas passing through a beam like the open path is. Yeah, it's really, it's looking and
seeing.
Yeah, the flame and the products of combustion are have to be in that cone where it's pointed at. It isn't something where you could have water vapor rising up from the ground and it's going to think that there's a hydrogen fire in front of it or something. Yeah.
Wow. Okay. Well, that's great. I feel like that really helped to deepen my understanding. Definitely each one, I think, yeah, you're right. It's very specific for what you're trying to do with each thing. So they have their specifics. Yep. I definitely think, another thing that I think we can help with too at Emerson is being able to help, map them out and determine where these things go, especially if the plant doesn't exist. I feel like that's when you're doing CapEx projects, these plants don't exist. So trying to figure out optimal locations can be tough, especially if it's an outdoor, and it's pretty tough. So I think that we have some services to help with that. Definitely. That's great. Now, what about, just in the last few minutes here, if you could just talk about, where you think the industry trends are going, if there anything that you're hearing about customers are asking for that maybe we're looking into that you can, obviously you can't share too much necessarily, but, where do you think things are going with the technology? I think it's going to be, more driven to the IR side of things. What are your thoughts? Yeah. Well, I don't know if I have any thoughts on, driven towards a particular, IR, UV, or some other type of sensing or measurement device. But as a general rule, I mean, the industry is moving towards more and more hands off. They want the proactiveness of the equipment and having it tied into a system and having it alert and what have you. So, where we're headed in the future, I think, is just a lot more interconnected and devices that can coexist with one another and kind of share their information. And, Emerson has kind of already gone down that path with, Plant Web Insight is maybe something that you've had a podcast on in the past. That's kind of the whole impetus behind that is take the outputs of a pressure transmitter and a temperature transmitter and a vibration transmitter, what have you, and convert that into, is my XYZ asset still functioning within spec, or is there a problem I need to go investigate? So you integrate. Yeah, so you're taking all these different measurements and you're analyzing what that actually means for a customer. So, I think we're just going to go further and further down that path of trying to get more analytics, more ability to kind of share between devices to make predictions and
help customers. You know, the big problem everyone's facing is having enough workers to safely operate and safely produce whatever that plant is working on. And so anything we can do to allow people to focus on the important tasks and take it off of their plates, the better. And so we want these devices to not false alarm. Let someone know when there's something to address as early as possible when it's easier to address. That's the whole kind of value message of the Incus is when it's a pinhole leak, it's a heck of a lot easier to go out and fix than when it's a major gas release. So
totally. Or on fire.
Yeah, exactly. So that's kind of, I think, where we're headed is just
that makes a lot of sense.
More interconnectedness.
Totally.
Yeah.
Great. Well, thank you, Trent. Really appreciate you coming on the show. Anyone listening, if they have any questions, they want to learn more, maybe can you point them to the right resources?
Well, we always point people to emerson.com. And I also recognize that that's not always the easiest place to point people to because there's a ton of stuff there. And even those of us who work for Emerson sometimes struggle to locate what we're looking for. But emerson.com, there certainly is a flame and gas section there where you can see all of our products and go from there and then reach out to your Lakeside folks for more help and more direction beyond that, I'd say.
Yeah, awesome. Great. Well, thanks again for being on the show. I really appreciate it. And until next time. Thank you.
Thank you very much.